Okay, good afternoon, everyone. I think we can start our webinar now. I'd like to welcome everyone again to another webinar of the Zambia Mathematical Sciences Association. So my name is Moses Mwale, and I will just give a brief background to ZAMSA, and then after that, I'll straight away invite our speaker to conduct the webinar. So I think I've seen that she's already joined. So ZAMSA, or the Zambia Mathematical Sciences Association, is really an association which was created to promote mathematics in Zambia. So this could be the learning of mathematics, the teaching of mathematics, or even the application of mathematics at all levels. And so the association is based at the University of Zambia, but we do accept with membership, and we do have members from all sectors of mathematics in Zambia. And so today's webinar is an introduction to geographical information systems. Our speaker is going to be Mrs. Nasreda Matende, who works as a GIS statistician at Zambia Statistics Agency. I've seen that she has already joined, and so I will immediately ask her to start her presentation. Yes, to take the screen. Thank you so much. Nasreda, how are you?
I'm fine. How are you, Moses?
Thank you. I'm fine. Thank you so much. Do you have a presentation which you'd like to share?
Oh, yes. Do I send it to you or I share my screen?
I think you should be able to share your screen now.
Okay. Just a minute.
Okay.
Are you able to see my screen?
Yes, we are. Thank you.
Okay. So good afternoon once again, ladies and gentlemen. Thank you, the Mathematics Association of Zambia from the University of Zambia for this opportunity. I'm really grateful. Maybe a little bit of a background about myself. My name is Naslele. Most people call me Nasi. I am a GIS statistician at the Zambia Statistics Agency. We used to be called Central Statistical Office, but now we are slowly transitioning into an agency. Yeah, and my background is geoinformation, science and earth observation, and also I have a background in geography. So we can straight away go into the presentation. My presentation is going to focus on the following key areas. Basically, what is GIS? What are the types of information that are integrated in the system? How do we apply it? Like if I want to apply GIS, what are the areas of application? And then what are the available softwares out there? Since this is an introduction, we couldn't straight away go into how to use a particular software. We needed to first of all lay a foundation. So in this scientific world, I'm sure a lot of you have heard this term, what is GIS? What does it mean? What does it stand for? GIS is just a computer system for capturing, storing, checking, and displaying data related to position on the Earth's surface. I think you have a lot of data capture systems around. You have data capture systems, for example, that are questionnaire based. You have all sorts of data capture systems, but what makes GIS unique is that the data that you are capturing is related to a particular position on the Earth's surface. So the acronyms GIS stand for Geographic Information Systems. So geographic information, like I already said, when you talk about geographic information, you're looking at mostly its location. Where is this located? For example, the Mo Manda Hill, where is Manda Hill located? If you want to know, for example, where the government is currently implementing a particular project, you want to know the where. Where is that place located? So mostly geographic information has to do with the current location of a place on the Earth's surface. You also want to know the knowledge about what that thing is. Where is it? When? So all these data information put together are what form a system that we call GIS. So I'll take you to my little picture over there. You see GIS in the center there, that there are a number of components that make up GIS. My apologies, my voice is a bit cracky today. So it doesn't stand alone. For GIS to be effective, of course, we have the softwares, like I've mentioned. There are a number of softwares that are used as a tool in itself for this GIS. For example, you've heard of open source software such as GIS. You've heard of paid for software such as ArcGIS itself. Those are just some of the examples of GIS software. Then also GIS is also made up of hardware. For this software to function, you need to have some hardware on which it could function. It could be a laptop, it could be a computer, it could be a tablet. Then GIS also, for it to be able to answer questions such as the when and the where, it also performs analysis functions in itself. And you cannot perform analysis functions in isolation of data. So data has to be integrated into this GIS system for it to be able to give you what you want to know. And then this system cannot be run in isolation. It has to be run by you and me. In this cycle, we are the people. We have to sit. You have to make a decision. What do you want to do? And what is the result? Just like any other analysis that you have to carry out. So again, information is about places on the Earth's surface. For example, you see my little map of the Earth there, and we see that there's this little tree that is located somewhere in Africa. And then you've seen those numbers there, those are what we call latitudes and longitudes. So this coordinate information is speaking to the where is this particular item located. So the GIS system is able to integrate also attribute information. If this tree is, for example, what I'm looking for, what are the attributes about it? For example, what is the type? What is the height? How old is it? Sometimes this is information that we collect maybe in surveys. We conduct surveys and then we collect different information. When we combine this information with coordinates, we put this together into a GIS system. So in short, that's what brings me to my little equation there, which says maps plus data is equal to GIS. This whole component works as a system. So you have the data, you have the hardware, you have the software, you have the people. All these are linked together as what we call GIS components. And behind all this, there's a science. For example, in a GIS software, there are science models involved. You can do sampling, you can do spatial analysis, and all those other statistical components that are in any other statistical package you can do here. That's where we say there is a science and a theory behind GIS. How does this work? GIS stores information about the real world as a set of layers. So for example, you need to have different data sets. We call them layers in the GIS language. You've seen, I've given you a little picture down there showing a number of layers. For example, you have the satellite image itself. I'm sure you're familiar with the satellite image. You've seen one maybe on Google Earth. Over that, you could have coordinates or points information you collected, maybe different households or location of areas. Those points could have attribute information stored in a table, but that is linked to that point. And all these put together, we come up with what we call thematic layers that can be linked through these geographic features. So what you just need to know is that GIS is a simple tool. It's just a tool that we use to solve problems. For example, in Lusaka, we have this problem of flooding, and you want to know how many households are affected by flooding in Kanyama, for instance. The rains have just come. They've hit us terribly. I think we've heard reports of roofs flying up, and things like that. So sometimes we want to know how many households in a certain location are affected by floods. So we will use this as a tool to conduct that analysis and be able to know the households that are affected. Then sometimes we have, for example, people are settling everywhere. We have these unplanned settlements that are mushrooming here and there. So you find that those settlements are lacking certain services. And so sometimes you want to know how many people live within a certain settlement, how many people live within, how long does it take for them to move, for example, from the hospital to, or from their home to the nearest hospital, from their home to their nearest water point. So this is the GIS tool that we're going to use to conduct that analysis and to solve these practical problems. The types of data that we use in GIS, they're basically, the main ones are three. We have vector. So under vector, we have point data. So we are talking about points that are described using coordinates, that's latitudes and longitudes, X and Y coordinates. Then we also have lines. So under lines, you have what we call polylines. For example, a road, that's an example of a line feature in GIS. Then we also have polygon data. So under polygon data, these are just like, you know, a polygon, the way you describe a polygon in itself. So you could have polygons, for example, showing we could have polygons showing parcels of plots, for instance, which plots are available in this particular town, which plots are available in this particular district. You could also have polygons showing the administrative boundaries. For example, here in Zambia, you know that the administrative boundaries are from the province level, the district level, the constituency level, up to the ward level. So these kind of data sets are going to be in the polygon data. Okay, then point data sometimes is just a point showing the locality of a place. For example, you could have point data for schools. Where are the schools in Zambia? So these will be represented by a coordinate. You get a coordinate, and those are going to be imputed in the GIS database as a point data. Okay. Then we also have, under raster data, we have images. So for example, you could scan an old topographic sheet. That could be an image. You could also have a base map. We have a lot of base maps on the internet now. All those are examples of images under raster data in a GIS system. Then we also have gridded data. Gridded data also comes in the raster format. A good example is you've seen data files showing elevation, for example, elevation of a country. You've seen files showing population distribution, for example, density. Then this is an image. The darker it becomes, the more populated the area is, the lighter it becomes, the more sparsely populated an area is. So this is just one type of information as well, which is called raster. Then we also have attributes information. Most of us here are very familiar with attributes information. These are more tabular in form. So you could have, and mostly they have non-spatial characteristics. Non-spatial meaning usually they don't have coordinates or anything like that. So there could be tables describing things. For example, you could have an attribute describing a building. So under a building, what are you going to describe? You describe, for example, the locality. What is the name of the locality? What's the area of the, what is the plot size? What is the height of the building, roof type? What are the building materials used? For example, what is the name of the owner of that plot? How many people are actually occupying that place? These all together are what we call attributes. And these are integrated in our GIS data as types of information. I'm sure you would wonder how GIS came about, what kind of disciplines contributed to GIS. GIS is a convergence of a number of technological fields and traditional disciplines. That's why people call it an enabling technology, because it just doesn't offer a service to one field. You find that you can apply GIS in an architectural background. You can apply GIS as a health specialist. You can apply GIS as a population scientist like myself. You can apply GIS in remote sensing. You could apply GIS in agriculture. You could apply GIS in computer science. And that's why we say that a number of technological fields converged together to come up with this system called GIS. So of course, the main contributing discipline was geography and cartography, because cartography has to do with maps. So GIS looks at visuals, how you display maps. Then we also have contributions from the field of remote sensing. Remote sensing here, we are looking at satellite imagery and such kinds of data sets. Then we also have a contributing field, surveying and photogrammetry, computer science in itself, mathematics and statistics. So all these different fields contributed in one way or another to come up with GIS. Why is GIS important? It's important because it's a powerful decision-making tool. For example, if you wanted to know how many people live in a particular settlement, you could have a table showing you people who live in a particular area. But when this is distributed spatially, you then begin to understand the exact areas where these people are located. Then also it's important because it allows for analysis, a lot of different types of analysis. For example, analysis of environmental data, analysis of demographic data, analysis of topographic data. Yeah, and then there are a number of applications which have now come up also, which are GIS based, that are being used in a number of industries and businesses. So the application of GIS is only limited by the imagination of those who use it. Pardon me, my voice is a little cranky today. So it really depends how you want to use GIS. For example, we have a way we use GIS for the census because I work in a census office. In a health background, they could use GIS to look at their coverage. How many people have they going to a particular health facility? You could have GIS to look at an environmental database, what is going on, climate change, which areas are being affected by climate change, So GIS has a wide scope of application in itself. Okay. There are various types of applications. So for example, in research. So in research, I'll give an example of where I work. Where I work in research, sometimes you have data that was collected in a survey and you want to see the spatial distribution of those data sets. So when you want to see the spatial distribution of those data sets, you are going to get that attribute data, attach it to a shapefile, and now do your spatial analysis, and you're going to have maps that are showing a number of indicators. Then also in research, you could use it like, for example, if like in our case, we also use it if you want to prepare base maps. You want to prepare base maps, you want to send people in the field. So you'd prepare base maps to tell them, okay, my field of study is here. This is the area where you go. And we give them applications they can use that will help them navigate. How do you get to that area? What features are you going to find? And even as they are collecting that data, because it has coordinates, you're able to upload it and see how your data collectors are moving. Then GIS also can be used in urban planning. It goes without saying, like I've already said, you want to build, you want to increase the number of services for the population. You want to build more hospitals. You want to build more schools. This is a tool that can help for that. Then also it can help in transport planning, navigation and routing. You find that sometimes government wants to decide where they're going to put a major road, where they're going to put a minor road. All that analysis can be done in GIS. Disaster management, like I said, there are some disasters that come up. For example, flooding. You want to know how many households are affected by floods. You want to know the location of those areas. So GIS gives a very good base for this analysis. Land management, you want to zone areas. Which types of land are we going to assign for agriculture? Which types of land are we going to assign for this type of use? Natural resource management, which areas are purely forest reserves, for example? Which areas can then be used for recreation facilities? Which areas can then be used as national heritage sites, and so on and so forth. You also want to do risk of vulnerability assessment. You could easily do this in a GIS environment. There are a number of risks that come up. Then the other applications of GIS, for example, you've heard about mobile GIS, where we have tools on the phone that integrate GIS functionalities. For example, even on your phone, I think every one of us, we have that little maps icon. We have that little maps application that we use if we want to decide the route. Where am I going? Am I going this way? Am I going that way? We also have mobile GIS applications that are used now for data collection. For example, Esri, they have come up with very good mobile applications for data collection that are also very versatile with GIS functions. And also, we also have like on WebGIS, this is where you see a lot of data portals. You have, people have put a number of data sets on the website, and then these are mapped. For example, you want to see how a particular indicator is looking in a particular area, you log into the portal and you're able to view some web maps. Then also GIS is now being actively used in precision agriculture, where people are estimating things like crop yield. They fly a drone over a field and do some analysis using the drones and also machine learning. Then we also have advanced uses of GIS, for example, building footprint extraction, where machine learning is being used, more of the computer science side and GIS to kind of tell people where in Zambia, for example, are buildings found. So they'll get a satellite image, run an algorithm on it, and then after that, it will be able to pick what is a building on that image and conduct some spatial analysis. What softwares are available? There are a number of softwares. As you can see from my presentation, there are quite a lot of softwares that are listed for GIS. The most common ones, the Esri softwares, ArcGIS. Of course, it's paid for. You can't use it without having a license. Then also you have QGIS, which is free, open source. And then there are a number on this list. I'll share my presentation after this. You could go in and see what that particular software is able to do. Yeah, so this is just a continuation. Quantum GIS, QGIS, like I said, which is the most common GIS mapping software that is available for you and I. In summary, GIS is a computer-based tool that we could use to perform analysis, such as creating maps and other phenomena around the world. Then it's combined by a number of components. We have hardware, we have software, we have data, we have human beings, and we also have methods that are tied to this GIS system. And then also we can state that GIS is a very important tool because we use it for decision making. If you want to know the spatial distribution of things, you want to know where things are located, you want to see how your data is being represented in geographical regions, you then use GIS to model this. So I think I will end here unless I have any questions, comments, or contributions. Thank you very much for your attention.
Okay, thank you so much, Nasilele, for that wonderful presentation. You brought out so many insights, what GIS is and the applications and the use of GIS, and it is really an enabling tool. I think from this time, I would like to open the floor for any questions which people may have, or any clarifications or any comments or any additions. So we didn't give the ground rules at the beginning, sorry for that, but if you have a question, please feel free to ask. You can type it out in the chat, or you could just raise your hand or just unmute your mic and you can ask the question. So if there are any questions or comments, feel free to ask. Thank you.
Yes, please. Can I ask a question?
Yes, please go ahead, Mrs. J.
Okay. Nasilele, very nice presentation. And you talked about what GIS system is. It's really interesting. And I got the feeling that we can have some data, the point data, first of all, and we can see that on a geographical map. For example, if you want to know the population of districts, then we can have that kind of data, what you call it as point data, and we can display it on the map of Zambia so that precisely on a spatial scale, we will know what the population is. Very good application. Well, I just quoted here as I understood. But my question to you is that if you have some images taken by satellite, how do you integrate them to go back to the numbers? Because the satellite images are the pictures and we want the numbers or some quantification. How do you work on that? I end my question here and I'm seeking an answer from Nasilele.
Okay, maybe we can take two or three questions and then we can allow Nasilele to answer or make comments on them. Is there anyone else with a question? Okay, then Nasilele, you can address the question from Mrs. Jane.
Thank you very much for that very good question. Indeed, GIS is a very powerful tool that we can use to represent population on a spatial scale. The question you asked is very, very, very precise and very good. You have images from a satellite and you want to know how you can extract numbers from there. So it's not a very straightforward process. Normally, there are models involved. So for example, I could take you to, there's a project that the UN is currently doing under the Grid 3 project. I will share their website in the chat. They have population projections that they've already done. So what they do is they get a satellite image and then they get other data sets. Then altogether that combined forms the model. Then when they get survey data, they get the satellite image, they get the building footprint and other data sets. They've explained a very detailed methodological document. Then they come up with a model. When that model is done, it then represents that information in an image form. So it then interprets the population at a grid cell level. For example, per 100 by 100 square kilometer grid, how many people are there? I think that's as far as people have gone in terms of interpreting population to a gridded, so they are called gridded models. They've already done them for you. You don't need to labor to have to do them again, but probably you could go through their methodology and then maybe contribute on how it can be improved. I hope I've answered your question. Thank you.
I got some sense, but it looks like to me that if you have an image, you have to have a model or some kind of estimation by which you assign numbers to the colors, isn't it? That is what the model does, so that you can have, the quantification, spatial quantification. Is that the right way, if I've understood correctly?
Okay, thank you, ma'am. So what you are talking, there's two ways in which you can represent population information. The first way is if you have a table, for example, representing the population of Zambia by district. You could then incorporate this to your what we call a shapefile, the one that's just showing the boundaries of your district. So you could then append this attribute information that is describing the population per district. And then you could then just do a very basic spatial analysis and show the colors per district. So that one is one way in which the information is shown. That one is very simple. You could do it even after this. You have a shapefile of the districts of Zambia, for example. You have an Excel file of the populations per district. You could then just convert that to a CSV document, do a join. And then after you do a join, you then prepare your map, and then it shows the various colors showing the variations in population. That's one. Then the second one is where you have what they're calling an image, a raster image. And then based on the colors of this raster, it gradiates with time. Like for every 100 by 100 square kilometer grid, it gives an estimate of how many people are there per square kilometer, for example. So for that kind of advanced modeling, it's where I was saying, if you want to, that one is good because it's an image. And how you could use it is, for example, you just want to know the information, the number of people around a particular area. And maybe the population you have is at the district level. And you just want to know a smaller area, how many people, for example, in a particular settlement. You could then just draw a polygon around there and extract those numbers from that raster. So those are the two sources of how you can display the population information. And I will share the link on their of the website for the raster. Then in case you still have questions, I can still take them. Thank you.
Hello, this is Shida, just to come in. This is Shida speaking, just to come in and add more to what Anastasia just spoken. So about the imagery, actually there are quite a number of ways in which you can extract data. One of them, I think she did mention about machine learning. Most of the times, the most common process in GIS will involve us bringing in Python. Those who are familiar with using ArcGIS Desktop or ArcGIS Pro will know that we need to bring in what we then call ArcPy. So what the ArcPy does, it kind of gives us a wide range of options. Either we have to do a band extraction. So it will also depend on the type of imagery which you're working on at that moment. So if the imagery is a raster imagery normally will come with attribute tables behind it. What that means is that the imagery has got data in the tables. So you can easily extract that data based on your interest. The other one is if you've got OpenStreetMaps, let's say Google OpenStreetMaps imagery. So that one doesn't really come with so much information. It will now come down to you. What do you want to do exactly? If you want to do, let's say, an overlay different data sets with that imagery, you can go ahead and probably use Python to do that for you. That is, if you're familiar with that. Or you can still build a simple model in ArcGIS Desktop. There's a function called Model Builder, where it just allows you to kind of get different tools and then extract the information from what you want to do. Then the other option is to use what they call digital elevated models. They're called DEM. So those ones normally would also come with quite a number of information with it. So that makes your life easier because data is already there. But so it all depend with what kind of imagery you're looking at. If it has data, it becomes simple. But if there's no data, then meaning you have to do a lot of manipulation for you to kind of make sense of what you're trying to do. So like she mentioned, the grade 3 guys, the guys that are trying to do a project with the UN, actually their website is kind of open source and they have quite a number of interesting things there to do with how the whole information is being developed, as well as the methodologies that are using. So when it comes to imagery data, it all depends with what kind of imagery you're looking at. Otherwise, it will depend with the image, and that will also influence the kind of process you want to induce. Over. Thank you.
Okay, thank you so much, Shida, for that addition. I have a question here in the chat from Professor Jane, and I'll just read it the way it is. And so it says, can you please elaborate on one application in a specific field. So, for example, in agriculture, how can GIS be used to guide which land is suitable for what crop? I'll add another question to that is, does RDA have a highway management system which is integrated with GIS? So just those two questions. Thank you.
Moses, could you read the last question again as well? I didn't get it, sorry.
I think the last question is asking about highways. So let me just add to it. Do we have maps which are capable of showing our road networks and infrastructure in the country?
Okay, thank you very much. I'm going to start with the last question. Those maps are available. I'm not sure if RDA has a GIS department, but I know that they have GIS data representing roads, representing highways, and representing all the road networks in Zambia. That information is available from RDA. As to whether they particularly have a unit that handles all this, I'm sure they have a unit. I'm sure they have a GIS unit that handles all this, but I know that they normally supply us with data on the road network in Zambia. If you want to know the roads by type, by name, and things like that, we're always able to get them from RDA. Then I'll go to the second question.
And the first one was on up. Yes, please.
On applications of agriculture. Okay, so there are a number of ways in which GIS is being used in what they're calling precision agriculture. So the first thing they do is mostly for this to work, they use high resolution imagery. That's why in my presentation, I gave an example of the drones. So if this is your field, they will fly a drone to that area, and then they will then process those images. I think Shida mentioned there's a lot that you could now do in ArcGIS Pro, where you process this data and you're able to come up with some very interesting analysis. So for example, when they process this data, what it needs is you need to have enough good training data for a GIS model to work. So for example, you need to, when you get your images, you need to classify them. So you, for example, you do the classification, you say, okay, when this image shows this, this represents maize, this represents beans, this represents groundnuts, and so on and so forth. Then after that, they use also the image itself has other, I don't want to be so complicated, other data sets that come with it. For example, you're able to calculate NDVI and other things. So when they do this, they're able to, for example, there are some interesting models that have come up where they're using this to estimate crop yield for a particular area. They are using this, for example, they're using this to estimate crop yield, and also, for example, to see which crops are not doing well, which crops are doing well, like using what they call maybe looking at the spread of disease by using something like leaf area index and so on and so forth. I'm not a specialized person in this field, but there's a number of interesting studies. If you Googled precision agriculture in GIS, that you could find. And there are also some people also have tools that they are using. I think there's another website. I'll try to check it as the chats are going on. They are doing some interesting work also on precision agriculture. They work with farmers, small scale farmers, where the farmers take pictures, they take images of their crops. Then when you also have now the satellite image, this is combined, trained in a model, and then they see how the crops are performing, and they conduct some analysis, and then the farmer is able to make decisions on that. I hope I've managed to answer. Anybody can feel free to add.
May I have one follow-up?
Yes, please.
Suppose I'm buying an agriculture land, and I want to know what the soil is good for. So you will fly a drone over there, and the drone will take pictures, and those pictures will show somehow that it can grow groundnut, or it can grow fruits, or it like that. some color of the pictures or what?
So for that particular use case, you need to do some analysis on the soils. So for example, yes?
I just wanted to respond to his question quickly. So normally what will happen is that when we fly a drone over a piece of land, right, that drone will capture geographic information as well as the geological features. So the geological features will then contain the type of soil, precipitation information, the temperature, and we'll be able to project what the soil will look like in the future. That is, if it's to be used for farmland. And we are able to project what would be the best crop for that kind of soil. Because remember, we have the soil information as well captured. So then what we'll then do is that we'll then kind of employ what we call a geological, a geophysics survey. That survey will then determine now, we'll have to go get samples on the ground. Now, after doing the analysis of the pictures, we have to go on the ground and confirm that whatever we captured on the pictures as is on the ground. So the survey will then involve us doing sampling that area, get the soil samples, analyze the quality, analyze the content. So it will then kind of bring in the geology aspect in it. So when it comes to farmlands and all that, we normally incorporate geology in that. We don't only use GIS, but we bring in the geological feature aspect in that. Then we'll be able to kind of give you a summary in terms of how good is your soil, what kind of soil it is, the temperature, the precipitation numbers, and all that. So that will give you an overall picture in terms of what you can plant here and what's good here. Sometimes we go as far as doing what we call airborne exploration. This one normally involves us sending what do you call this? Would send rays into the ground, right? And then depending on the machine we're using, the ground will respond with whatever minerals are in that ground. That is in the case where we want to find out what minerals are in that piece of land. So it would normally combine the two, GIS as well as geology. So I hope that helps to clarify. When it comes
very
to
clear. So you mean will the picture from the drone will not be enough to provide you what kind of soil it is? You have to do actual sample testing of the soils also.
The pictures are enough, but it's recommended just to kind of do a soil sampling because some of the components might not really be captured, from the drone pictures. Sometimes I'll give an example of we had a study in Kabwe where we wanted to determine the level at which the lead has contaminated the areas. In as much as there was information to do with the imageries, we went on the ground and sampled the soil just to get as much information as we can.
Okay, thank you.
Can I come in, please? Just to add on what Shida has explained, I think there is there should be a map, a soil map for the whole country. I think when you Google, that map should be there, it should be available. The reason why you do in fact, you do the geochemical sampling. Geochemical sampling will tell you what type of elements are in that soil. If you look at the whole country, Zambia, you find that the type is divided into zones. There are zones that are good for agricultural purposes, and there are those that are not very good because of maybe leaching and the type of rocks that are there. Because after all, the soil comes from the weathering of these rocks. So when Shida talks about the geochemical sampling, geophysical sampling, he's also trying to say that we need to analyze the type of elements that are in that area that you want to farm. So different areas will have different types of rocks, different types of elements, minerals that will support the type of crop that you want. So the start should be, maybe if you want to do the farming, should be you look at the map that has been already done, and then try to do the geochemical sampling for yourself so that you test the soil elements that are in that area. Thank you.
Okay, thank you.
Okay, thank you so much, Shida and Julius. Are there any other questions? We can take one or two more questions, I think, before our time runs out.
Okay, maybe just hello. Can I go ahead?
Go ahead. Go ahead.
Yeah,
yes, we can.
Maybe just a question should be that after learning this introduction to geographical information systems, what's next?
There's actually a question, a similar question to that effect in the chat, where people are asking, what are there any institutions in Zambia where I can learn GIS? So let's say after the introduction, I'll ask Naslele to take this one. Where can we get more information on GIS and how we can apply them in various fields?
Okay, thank you very much, Moses, and thank you, Julius and Shida, for the very helpful contributions. So where you can learn more information about GIS, of course, the first place you could learn is YouTube, Google, but then there are institutions in Zambia which are offering short courses. For example, University of Zambia, I know they are offering some short courses, like 1 week or 2 weeks to learn GIS. And I think there are some schools also being run by the forestry department. They're also offering a short course in GIS. But if you need any other information, I think I could share my email, then I could email you some schools or whatever that are offering a short course. And then there are a lot of free courses online, by the way, a lot of them with this COVID that you could follow remotely and gain a skill or two, and they're free. So I think that can be information that we could share and circulate after this. Then the other question that came in and said, what next? My job was to give an introduction to non-GIS users about what this field is all about and what it can be used for. So after this meeting, I guess the organizers can advise, although it would be nice to then move into, I think, more hands-on topics, especially that we have a number of specialists, even in this meeting and also around the country. Then we could choose themes and we could have some very good hands-on interactions. I think it would be very interesting. Thank you, Moses.
Okay, thanks so much, Naslele. I think you have done a wonderful job of introducing GIS and also sparked a lot of interest in what GIS is and how we can get further information about it. As ZAMSA, we will see if we can have specific applications of GIS which we can focus on. Then we can invite some speakers to come and handle certain aspects of GIS spatial data. Just two final questions which are in the chat. Another question here from Francis, who is asking, and on applications as well. So how can GIS be used by utility companies like Lusaka Water and Storage Company and ZESCO? And then the second question from Peter is, how can GIS be integrated in agriculture insurance products? So the first question is use applications of GIS by utility companies like Lusaka Water and ZESCO. Then the second one is on agriculture insurance products. Maybe you can take those two questions. Thank you.
Thank you very much. So in utility companies, actually, they can't function without GIS. First of all, they need to know the location of all the households, all the houses, all the buildings, all the structures that they are providing that service to. So they need to have that spatial database of the residents, where are those people located? Where do they stay and things like that? Then also, in terms of Lusaka water, they could have a database showing the lines, their service lines where they are passing. So then they could then do analysis. They could see which households are not taken care of, which ones are taken care of. And then in terms of when you have, for example, a pipe leaking, if they have a very good system in place, they can then use this kind of information to immediately know where the location is instead of digging aimlessly. So if you have a very good database showing all the information that they have, for example, as Lusaka water, they could then, and then also the other information that Lusaka water could use this GIS data, for example, is to do advanced spatial analysis, like for risks, groundwater pollution and things like that. So you could see where they propose, for example, their water lines to pass, and again, what things are nearby there that could then be a hazard to that water line. So that is a way in which, for example, Lusaka water and could use that. Then for ZESCO also, they could use it in a similar way. I know they have what we call them shapefiles. They have shapefiles showing their power lines. So they have this power line, that power line, and so on and so forth. So if they overlay that data on an image, they're able to see the areas which they are currently servicing. And then also they could use that to see the areas which are not being serviced. And also in terms of when you have a risk, a fire and things like that, when you have a proper live database, they're able to tell the exact location where this power line is, what disaster is there, and things like that. Then I think I can open it up. Anybody else can feel free to add in a comment. Those who've done projects with Lusaka Water and ZESCO on how they've used their GIS data. Thank you.
Okay, I think our time has even come to an end. I was supposed to end by 13 hours. So thank you so much to our speaker for the wonderful presentation, and also thank you to the participants, those who were able to join. So I think it's evident that we have so many professionals, so many experts in various fields, and so that's one of the functions of Zambia Mathematical Sciences Association, is one to bring people together, to connect them, so that we can know what are people's needs and how we can address them, and what professionals are dealing with what type of problems. And so I think that's one way in which we can grow together as a country. So for those who have got further questions on ZAMSA, to find out other activities which are planned by ZAMSA, we do have a link to the Facebook page. So please just online, and there's also an application for ship into the association. So once again, I'd like to thank all the participants who've been able to join this afternoon, and I think we can end here for today. So thank you so much, and have a good afternoon to everyone.
Thank you very much for inviting me, Moses, and thank you very much, everyone, for listening. Thank you.
Thank you. Mr. Moses. Hello. Mr. Moses.
Yes, I'm still on thing.
Yeah.
Yes, please go ahead.
Yeah, I would like to get in touch. I don't know whether you have an email address or phone number. Maybe if there are other areas of collaboration, maybe I can try to offer myself for such. think this is a wonderful topic, and it's a good topic. Yeah. So I don't know if there is anything that I can do, or maybe we can work together in future. I don't know. So I'm asking for your contact.
Okay, yes, sure. I'll just send the ZAMSA email address onto the chat, and everyone who has got any question or any ideas which you would like to share with us, please send us an email. We're going to read it, and we can pick up the conversation from there. Is that okay?
That's fine, sir. Thank you so much.
Okay, okay.